Hey everybody, this is Ken Rose and welcome back to the Level Up podcast where we talk with some of the brightest engineering and DevOps leaders about what it takes to build great products, teams, and companies. Today I am honored to be here with Daniel Gebler, who is the founder and CTO at Picnic. Picnic is the fastest growing online supermarket worldwide. Daniel has grown the team from humble beginnings to a team of over 15,000 people. And today we're going to be talking with Daniel about that journey and how he scaled engineering processes throughout the entire organization. So Daniel, thank you so much for joining us.
Thanks, Kenneth. Thanks for having me. Looking very much forward to it.
Yeah. So why don't we start? Tell us a little bit about sort of the early days at Picnic. You know, how did you meet your co-founder? How did you figure out that this was the problem to solve? And what did that kind of like V1 of Picnic sort of look like?
So V1 is already probably a little bit we are in tech, so it starts with zero. So the V0 was an MVP that came from a simple two observations. Number one is while we all feel very comfortable to shop for non-food items, so electronics, books, fashion, online, we are actually not yet shopping too much food online. This is number one. Number two, we saw that there's a lot of potential if we develop a little bit further the business model. So, for instance, moving from paid deliveries to non-paid deliveries, allowing kind of free deliveries and also lowest price. But the second thing is also moving towards an entire new technology behind the scenes that connects farm with fork in a very unique way. And that was basically the starting point where we thought, well, let's develop something that nobody has tried before with this kind of business proposition and build the technology behind it, launch it in a kind of test market, which was a kind of a small city not so far from Amsterdam, and see how customers are liking it. And that was a launch of just a few cars with a small team, and then thousands of customers actually wanted to use the service. And that was a very exciting time because we actually had only 4 cars. We had only a couple of order pickers. So how to handle that? So this was the first kind of hockey stick growth that we had to handle in a very creative way. And the way as we have handled that is that we have built a kind of a mechanism that balances supply and demand with a small waiting list that we still use now sometimes in order to get the right amount of customers in the shop that we can also serve.
That's really cool. It's almost like back pressure, but at like the product level. Like, hey, the queue is saturated. There are no more cars available. Like, you'll have to just wait a little bit longer.
Exactly. So this is a kind of a queue that we all know, obviously, in tech, but the same you can apply also to business models, and that's what we have done there.
That's awesome. And as you know, Picnic started to scale. Can you talk a little bit about how you went from that sort of scrappy MVP in that first version, and how you started to think about how your design process has changed as you went from sort of that startup mode to hockey stick scale up mode?
Yeah. So when we started, we actually focused only on technology for a small part of our business model. So we started only building out our consumer app and only building a small part of the supply chain, and have used for many other elements of the business, for instance, for customer service, for ERP, for warehouse management, etc., third-party services. And the reason why we've done is, number one is, well, we didn't have enough people, money, and time to build the first version, but even more, we wanted to really understand what do we need to build as a version 1 before we go in the scale-up mode. And that was at the moment where we actually used for every business function 2 or 3 services from the market to understand what is the current state of art, and then designed our own system to basically go beyond the state of art. And that was the way how we designed a completely end-to-end integrated supply chain, which is now kind of a Java-based stack, completely in-house developed and cloud deployed. But also connected this kind of supply chain stack with our consumer app. So that means that you can see in real time a bit when you order a product, where is it now in the supply chain? Well, when will it be at your door? But also when, for instance, is the asparagus harvested, etc.
That's really cool. It sounds like you actually have these 2 challenges. You're building both the consumer-facing app and having to have a great consumer experience, but also building a lot of the kind of back office and as you mentioned, like an ERP and warehouse management and routing and logistics. Are there different sort of challenges in terms of how you would think about software design for sort of the end user consumer bits versus the kind of like back office parts?
Essentially, for the consumer app, you focus more on the key user flows, and you try to minimize the functionality that you put in the app, and you try to perfectionize the user flows up to the point that customers are completely happy. For an logistical supply chain flow, you cannot drop, or you need to have, at least for the basic processes, some system support from the beginning. So there we actually went in different kind of phases, where in the beginning we built just MVP based kind of Python prototypes. At some point we built scalable solutions in Java. But even there we went through kind of evolutionary architectures, where we really in the beginning built implementations that could scale to a couple of hundred orders. But we knew that if you reach a couple of hundred orders, we cannot use this kind of architecture to scale further. We need to re-implement this. And that is acceptable. So a very fast launch of in a new market or with a new business model requires from our side that we have a short time to version 1. And then we give us a little bit of time to basically throw this kind of version 1 version away, and then build a scalable version 2 out of it based on all the learnings that we have from version 1.
I think that's a really, that's a good bias to have, right? That in a startup you are focused on building first, getting the learnings, and then, kind of reinforcing it in your second system. How did you communicate that, I guess, to your engineering team? Like that trade-off of kind of done is better than perfect. Like here's what V1 means. Here's the scale that it needs to get to so that we can learn. Because I'll observe sometimes engineers will bias towards like, no, we want to build the perfect system. We know how we can scale this, right? How did you kind of balance that trade-off with your team?
Well, it's a very good point, and actually it is completely against the nature of all of us engineers, because we want to build software solutions that we are proud of, that are beautiful design, that can very well scale to however many customers we will have. Now switching essentially the mentality to accepting that you build a solution that has actually a crappy architecture and will certainly scale only to a few hundred or a few thousand customers is a completely different type of mindset. And what we have done there is that as part of kind of the MVP implementation of the very first version, everybody took enough time, or also a bit of time, on designing the kind of the full-scale solution. Not implementing it immediately, but as designing the solution, which actually fulfills two needs. Number one is we got a non-scalable version 1 that we could trial. And number two, all engineers were very happy that if this trial is succeeding, that we have a very nice kind of a version 2 that we can build with a well-understood architecture where we had already a design for. So that basically fulfilled the entire need of engineers that want to build obviously a solution or an implementation that they can be proud of.
Got it. So it sounds like then there is a lot of design work that goes into thinking about like what the kind of the right or the perfect solution is. It's just very intentional that you folks will first build the scrappy version to actually validate that further investment is warranted in the more perfect V2.
That is absolutely spot on. And we are, even if we have built a solution that is scaling already from day one to maybe 1 million customers, we make a small retrospective afterwards where we try to understand, did we really build the lowest effort possible version 1, or did we not maybe over-engineer the version 1? And the reason for this is to keep everybody in mindset that we need to run as many as possible experiments in order to get a good understanding on what is the kind of the new feature set and feature package that we should build in the future, and where we then really build a scalable solution. And the main thing, and let's say the underlying learning for all of you readers and listeners, is that if you want to, in essence, if you have an experiment-driven culture, and if you want to really run a lot of experiments, the main driver of, let's say, your future success will be how many experiments can you run in a short time. And the interesting thing is, if you make this in a very short intervals, it doesn't matter any longer on which point you start. You can actually start on a pretty heavy level, but the exponential power of incrementing and improving step by step every week with a kind of a new prototype, a new experiment, will bring you anyway to a fantastic end result.
That's awesome. So the idea of these sort of compounding effects that you get from those experiments, it sounds like there's a distinction, because a lot of times, like, I'm run a startup, our focus is build really quickly. But it sounds like you're optimizing for something a little bit different. I was wondering maybe if you could, you're focusing more on rate of experiment or rate of change. I was wondering maybe if you could talk about that tension.
There's two things that we optimize for. We optimize for the rate of change, and essentially we want as often as possible change and improve the software in small increments. And we are not even so interested in how big the increments are, but the change rates need to be extremely high. That's number one. Number two, when we are looking into how do we design a software architecture, in the beginning we looked obviously how fast can we build version 1. What we are now looking into in the overall kind of system architecture is how can we optimize for the least possible effort for the first 10 or first 15, first 20 type of versions of a specific feature. So therefore we are looking into optimizing how easy can we change an architecture while moving from version 1 to 2 to 3 to 5 to 10, etc. So therefore we accept deliberately that version 1 takes a little bit longer if it gives us a lot of flexibility with version 2 and version 3.
Got it. So you're really maximizing kind of for optionality, that you have the ability to make changes, that the software is maintainable or not maintainable, but easily changed, as opposed to just kind of done and getting a V1 out there.
It is the traditional term is certainly maintainability, but I think the phrase that you use with optionality is actually a very, very important one. If you don't know exactly the future for what you will build, obviously you have a vision where you want to end up with, but we all build software systems that will launch in a couple of weeks, couple of months, maybe in years' time. Then we can be sure that whatever we assume now to be the reality in a year's time will be different. There's so much change happening, so we need to actually prepare ourselves that the version that we launch in a year's time, we need to change very quickly afterwards, because the reality is different than what we projected to be the reality in a year's time. So therefore we optimize already early on for this kind of optionality. And the interesting thing is, this is becoming even more relevant in a world where you combine a pure digital service with physical services. So we're building all kind of warehouse automations where you need to optimize also for all the physical improvements and physical advancements that are happening in either the car industry, where we are now having 3,000 cars on the street, but also in warehouse automation, where we are running warehouses of around 40-50,000 square meters with around 1,000 robots per warehouse.
I was wondering if you could tell our listeners a little bit about that. Like, when I think of just providing pure software solutions and digital services, there's enough problems there. Can you talk a little about, the late stage Picnic is now doing a lot of cool stuff on route planning and IoT and cars and logistics. Can you tell our listeners, a little bit more about the efforts you guys are doing, and also how you think of changing your software development process to incorporate changes in hardware and incorporating hardware into that mix?
So in the early days we built basically the version 1 of all kind of services, and these have been mainly digital services. So there's obviously a consumer app, there's a customer service app, there's a payment solution, there's kind of stock service warehouse management solutions. But what happens at a typical warehouse, as an example, works the following way. You have all kind of shelves, and there's an order picker. You go with a pick car to the shelves, and then you pick cucumbers, bananas, cheese, meat, and all this kind of stuff that customers are ordering. But if you go a step further, then actually that is a lot of work if you go as an order picker to the product. It will be much cooler if you have robots that bring products to you, and then you can basically assemble this in the consumer to it. And this is exactly what we did. So we built a system that is bringing products to you, and as an order picker, you're just assembling this together in the consumer orders. And these are warehouses that are actually really, really big warehouses where you have robots, where you have conveyor belts, we have big automated storage and retrieval systems. And from a software engineering perspective, there's a lot of very interesting challenges that you tackle here. On the one hand, this entire robotic installation process is actually a very kind of big waterfall type of project. So you're running Excel sheets with 10,000 lines of project plans on the one hand, and then on the other hand, you build an ultra agile CI/CD, ultra agile Scrum or Kanban type of software development process, over an extended time, so usually for a year or 2 years. And then you hope, no, not you hope, you want to make sure that you end up at the same point that you can launch both systems together. So that is a big, very interesting challenge. While we obviously love altogether these days the cloud, you're talking there about physical installations that have latency requirements for control software that are below 1 millisecond. So that means there's no general purpose cloud. Doesn't matter if it's Azure, Google, or any of those clouds that can that can fulfill those kind of requirements. So therefore, we have now also started to build a hybrid setup where there's already around 1,500 cores on-prem deployed, and then there's also a cloud planning solution that is connected with this on-prem infrastructure. And these are only 2 examples of the long list of 120 kind of challenges that we had to tackle to build this automated fulfillment center.
Can you talk to us a little bit more about, you mentioned on the I'll call it the hardware side, there's, like this massive waterfall deployment. I can imagine there's contracts with vendors, there's the setup and initialization and training. And then at the same time, that's sort of the one side. On the other side, you have this agile development team using CI/CD, using Scrum and agile methodologies. How do you reconcile that? Like, I agree. I love your point. It's like, yes, in a year you plan for these 2 points will converge. Can you talk to us a little bit more about some of the specifics of how you kind of work up or milestones you might set to get there?
Yeah. So what we did in preparation of this project, we talked to all kind of companies, small and large, big tech and small tech, old tech and new tech, to get a little bit of kind of a feeling on how different kind of companies are doing it. And to be frank and direct, nobody has a kind of a silver bullet. There's no easy answer to this kind of question. What we found, what has worked for us is that we are running an agile process with predefined milestones where you can where you have actually different kind of maturity stages of your system and also different kind of testing stages. So what you do is, for instance, you're building an integrated system where you can do factory acceptance testing, which is basically a big factory environment. It's not production, but factory environment where you can test the entire system. Then you have a so-called site acceptance testing, and then you have different kind of ramp-up kind of production testing that that is done there. And you run essentially, you combine those kind of different waterfall and agile work streams that are not at the end of the project coming together, but coming for every kind of milestone that is usually defined in months or 2 months iterations. You're aligning basically both type of work streams. But what is very interesting from a tech stack perspective, all those kind of high-level planning and control software is written on our side in Java and Python, so we are using a dual stack there. But if you go a little bit lower to the kind of the control software and the microcontrol elements for conveyor belts, but also for robots, you end up immediately in a PLC type of hardware and a software kind of elements that are, on the one hand, very, very traditional. So this is typically specs out of the 80s. So you get PDFs that are actually scanned images that define the specifications. However, and there's no way that you actually properly test this. So that means also you're using interfaces. So if you want to use a REST JSON, then it's just not available here. So you're talking about very, very low level interface, which is on the other hand also very exciting because you're talking about kind of micro optimization that goes more into the level of assembler type of optimization instead of high level object oriented automatic garbage collection type of development environments that we as software engineers are typically used to.
Yeah, it sounds like a lot more focus on sort of like systems programming and Rust
Yes.
and C++ and kind of like the programming of like the 80s and 90s.
Kind of, exactly, and then even before.
Yeah. As Picnic has grown, how do you sort of think about? There's this broad term called platform engineering, right? Sort of investing in engineering teams that help make the rest of your engineering organization move more effectively, reduce risk, ship faster. How do you kind of think about that trade-off at Picnic?
So the perspective on platforms and team organization and has changed quite a bit. What we started with a relatively small team now a couple of years back, where actually this was more kind of a feature teams and actually a product team to build the very first version of our consumer app and a couple of other systems. When we went in through the growth phases, or had a kind of 20, 30 engineers, then we started to build actual product teams, where we now have product owners and tech leads as a dual leadership team for the teams, and then a classical cross-functional teams. And then at some point, when we grew beyond the size of 10 product teams, we started to build domains around kind of a set of products. So for instance, all our consumer products form a domain, all our supply chain products form a domain, all our data solutions form a domain. And even more interesting, and in this context, coming back to your question, we have a domain that we call Foundation. And in Foundation, we have bundled everything what is platform in our context. And platform is probably an overused and often misunderstood term these days, and on our side, we have actually three perspectives on platform. On the one hand, platform for us is, if you're looking to a software product like a shopping app, then these are kind of the core services that are not only necessary for instance, for a shopping app, but these are also maybe necessary for a warehouse management system, for a route planning system, etc. Things like order management and transaction management, etc. However, there is certainly also platform, a perspective on platform that is more infra-related. So everything what you would consider more on the CI/CD deployment, build system, infrastructure, Terraform, Helm charts, etc., is for us a layer below, which is our infrastructure platform. And that is linked also a bit to the security platform that we have built. And then we have one, and this is the latest kind of perspective on platform that we have built, is a developer experience platform, where we are actually building where we are bundling together all the tools that help developers to deploy as fast as possible new pull requests into production. And we measure the effectiveness of our developer platform based on two metrics. How fast is a new joiner deploying his first pull request in production? That's number one. And then the other metric is, and we're still debating a bit about, is it a 10th or should it be the 50s or the 100th PR, where we see, okay, somebody is sufficiently mature and is basically part of the team, you can consider him really a productive engineer. So how long is it that he needs until the 10th or the 50s or the 100th PR? And what you see is that with all this kind of developer experience platforms, you can actually make a pretty big steps there. And there's obviously kind of a bigger debate about is this time to PR? Is this really a good metric? And we have obviously every tech organization has this kind of debate. But for now, we are at a point where we have a broad consensus and acceptance that that is something we should at least keep a close eye on. And with a little bit of context, certainly also can take it as a metric that we can steer on.
What were some of I totally agree, by the way, the idea of like time to first PR can be condensed. Were there any other metrics that you folks kind of thought about in terms of like evaluating the success of that investment in developer experience?
So the kind of the metrics, we have a long list of around, and we are using a bit of kind of the SPACE framework and a couple of other frameworks to really understand the efficiency and effectiveness of our development teams. The bigger the top line metrics that we are looking into is the time to nth PR. This is first 100, 10th, 100th. The other one is the number of pull requests that that a developer produces per week or per month. This is a very high level metric. What we observed is that over time, obviously PRs getting a little bit smaller because smaller PRs are easier to review, but the quality and the information density of pull requests is actually, for most organizations, pretty constant over time. There's big differences between, for instance, what is a pull request in maybe big techs and some smaller tech organizations. So a pull request in Uber looks really different than a pull request in smaller organizations. However, if you look a bit into a pull request in 2022 of Uber versus one in 18 and one in 15, there's not such a big difference. So therefore, you can actually use those kind of pull request metrics, so first or second order derivatives of the kind of typical developer metrics and velocity metrics, use as a pretty good measure also over time to steer or at least to understand what your development teams are doing.
Have you found, since you've implemented a focus on a developer platform and intentionality on specific like DevX metrics around time to first PR and time to MPR, what has been the change? Like, have you seen that the PRs have become more information dense, or that it's induced smaller PRs?
The most important thing what we found, there are two things. Number one is if you find a way to measure the amount of context switches that a developer is doing, you can massively influence this. And actually the metric for this is super simple. We have just an export. We are using clockwise for our calendars, and we are measuring how many actually meetings you do per day and how many focus time you have. Those developers that have more focus time will simply be more productive. Very stable metric, number one. Number two is the amount of time between, let's say, the gaps between the pull requests. When you see if somebody is really in a flow state, that you can work on an ongoing basis on maybe 2 to 3 PRs at the same time, then this is a fantastic, usually a very productive developer. If you have too many PRs, or if you have gaps between and working on one PR and the other PR, then you usually productivity drops massively.
Yeah, that it sounds like that like you're almost biasing then towards like maximizing focus time, and then which will induce then the number of PRs that can kind of get out per unit time.
We are, to be very frank, we are at the early stage of this kind of journey. We still need to figure out what really helps. What we do is we don't use it as we don't enforce a new behavior. We don't enforce a different way of working for engineers. What we do is we actually give a mirror to our engineers, where we say, in this week you had this amount of meetings, and you could actually create this amount of pull requests, or you could make this amount of releases. In another week where you have been super busy and all over the place with many meetings, you could only realize that. Would it not make sense maybe to organize meetings in a way that you have a little bit more focus time?
Yeah. There was a book I read years ago called The Effective Executive, and I think it was like chapter 3. It was like know thy time, and the entire thesis of that was like just measure where your time is going, because a lot of time where you think you're investing your time and where you actually invest your time are different. And I love this idea of like reflecting back to the engineers, like here's where your time went, and then here's the impact on like the number of PRs that actually got produced.
Actually, if you don't measure it in a structured way, nobody, it doesn't matter if it's an executive or if it's an intern who starts just as an engineer, nobody has really an understanding how you spend your time. So you need to start in a structured way, measure it and present it. We tried a few things. Now we can very clearly measure it over Jira and GitHub and different kind of metrics. We tried actually something very simple before. We had a small cube where you could select what are you currently working on, and then it was connected to a recording device where we recorded a bit of type of tasks that you do. So now you're working a bit of architecture, now you're working a bit on product meetings, and now you do actually deep thinking or software development. The thing is, as long as you need to do self-reporting of the work, and especially switching between types of work, it doesn't work. So the kind of the analogy that I'm using now for this is a bit like those kind of food trackers that a lot of people are actually trying to use in January, because they have a New Year's resolution. It works actually for the first 2 or 3 weeks in January very well. It doesn't work for none of the weeks in the rest of the year. Sometimes in May, if you want to get back to your beach body, but there's no moment else.
I'm laughing only because, Daniel, as you were describing the opt-in, I went on vacation over the summer, and I got back and looking at the pictures like, I think I gained some weight. And I started with the calorie tracker and the opt-in. It's great the first few weeks, and then it kind of fizzles out. And I love that you picked up on the exact same analogy.
No, it's very obvious. It's also very easy to understand, which is, by the way, in the health industry, probably the biggest challenge that the industry has. So we have the fitness tracker. So let's say your calorie burn is in a very, very stable way tracked these days. Mm-hmm. Calorie intake not.
Right.
And if you find a solution for that, then that is basically the next 10x or 100x for the entire health market.
Yeah, to make it passively collected versus something that you have to actively kind of input. Awesome. Well, Daniel, before we wrap up, I always like to ask people, what is your favorite music to listen to when you need focus time or when you're doing kind of deep work?
Yeah. So there are kind of two modes. Sometimes I don't listen to any music, just noise cancellation. And if I listen to music, I love to listen to smooth jazz. So there's a site smoothjazz.com where you can basically for free listen for hours for just kind of a deep thinking jazz. It is so much kind of background music that it doesn't distract in any way, but it helps you to stay focused on whatever you're working on.
I'm gonna give that one a look. I always just kind of use the music service, but I like free, and smoothjazz.com will be one to look at.
Yeah. By the way, you'll find it also on Spotify or whatever service you use. Yeah.
And Daniel, what's the best way for people to follow you on social media?
I'm not overly active in social media, but you're definitely invited to follow me either on Twitter. My handle is Daniel_Gebler, and you will also find me on LinkedIn.
Awesome, great.
Yeah.
Well, everyone, feel free to follow Daniel on Twitter and LinkedIn. We're going to be including those handles in the information in the show description. Daniel, it has been absolutely great having you, and I super appreciate you taking the time to talk to us today. For our listeners, we learned about biasing towards experimentation, how to reconcile sort of hardware and software in your engineering organizations, and we also talked about platform engineering and how to use metrics to drive developer productivity. So thank you to all of our listeners for making it with us to the end and listening to today's episode. And if you have any topics or guests you'd like to see on the show, please send us an email at levelup@opslevel.com. Daniel, thank you again, and we'll see everybody next time. Happy building.